Hello grade 9s and welcome to another video with me, Miss Martins. In today's video we are doing some algebra, we're doing factorizing, exam questions. If you haven't seen my first video where I explain the difference between simplifying, factorizing and solving, you're going to click the link above, but for now we're going into factorizing. I also have some factorizing videos on my channel, so go visit my grade 10 maths playlist. I go through highest common factor, difference of two squares, trinomials, just so that you can get the basics, because today we're looking at everything. We're combining everything. We're going to practice some exam questions. Let's go. Now, first of all, when you see the instruction factorize fully, we know that factorizing is the opposite of expanding or distributing. So when you expand, when you multiply into brackets, we get rid of the brackets and then we add or subtract like terms. Factorizing makes brackets. We end up with one term when we factorize. So here, do you see, we start with a multiple, a variety of terms. So here I have two terms, here I have two terms, here I have three terms, and so on. When we factorize an expression, we're going to end up with one term with multiple brackets. So factorizing makes brackets. And over here in grade 9, these are the types of factorizing that you need to know. Highest common factor, that is the one that you're going to try first, always. Highest common factor, it can include a common bracket as well, which we will get to. Then difference of two squares, which I abbreviate to dots. And we use dots when we see two terms and you've already attempted highest common factor and it doesn't work, then you do dots for two terms and a minus in between. Then trinomials are for three terms. So let's just jump right into our first exam question. Note how the instruction says factorize fully, so your mind immediately needs to go to highest common factor. That's the one that you always try first. So you look at how many terms you have, and we have two terms. And you ask yourself, is there anything that is in common that I can divide each term by? What is the biggest, what is the highest factor that they have in common? Now, another way to write this would be 3 times y times y times y minus y times y. So I know that we don't generally in an exam look at it like this, but this helps us to make sense of what's going on. The biggest thing that we can divide both terms by would be y squared. Because do you see this term has a y squared? It has y times y. This term has y times y times y. So we can divide it by y squared. Okay, so my rule is you always look for the biggest number that can divide into both coefficients. This we just have a 3. Here we have a 1. So we can't take out a 3. Then you look at your variables. You can only take out a variable if they're in both terms or all the terms. So for example, if I didn't have a y in my second term, then I couldn't take out y. Okay? If I had a third term over here that said plus x squared, then I can't take out y as part of my highest common factor. So it needs to be in all of the terms. So because I have two terms here and they both have y's in them, I can take y out as my highest common factor. However, when you take out a variable, you always have to take out the variable with the lowest exponent between the two terms. So we've got y cubed versus y squared. Which one has a smaller exponent? Y squared. So I take out y squared. Y squared is my highest common factor. Then we open up what I call my leftover bracket. And then what you do is you say 3y cubed divided by y squared. That leaves us with 3y. Okay, so you take the first term, 3y cubed, you divide it by your highest common factor, y squared. What you're left with is 3y. Another nice way to think about it is, what must I multiply y squared by to get the first term? So y squared multiplied by 3y gets me 3y squared, because you say y squared plus y to the power of 1, that's where the y cubed comes from. Then we've got negative y squared divided by y squared. Negative y squared divided by y squared is going to leave me with negative 1, because that's going to cancel with that, leaving me with negative 1. Another nice way to think about it is, what must I multiply y squared by to get me negative y squared? Well, I need to multiply it by -1. And there we go. We have factorized fully, and that is your answer. So as you can see, we are left with one term, and we're left with brackets. My next question, 1.2, again, it says factorize fully. My first step is always to ask myself, can I take out a highest common factor? Remember, we have to look at the big numbers, the coefficients, 16 and 9. Are there any numbers I can divide into 16 and 9 without a remainder? No. Okay. Then we see, can I take out an x? No, because my second term doesn't have an x. So highest common factor does not work. My next type of factorizing that I consider is called difference of two squares. And difference of two squares will work if I have two terms, which I do, a minus between my terms, which I have, square numbers. Okay, so can I square root the numbers to give me a whole number? Yes, I can square root 16, it's going to give me 4. I can square root 9, it's going to give me 3. And even exponents. So these exponents here must be even. If it meets those criteria, I can do difference of two squares. And difference of two squares involves two brackets. You're going to put a plus in the one bracket, a minus in the other. It doesn't matter which bracket gets what. And then you're going to take your first term and you're going to square root it. So the square root of 16 is 4. You're going to put that in at the start of each bracket. The square root of x squared is x. It makes sense because x times x will get you the x squared, and 4 times 4 will give you 16. Then you do the same but with 9. The square root of 9 is 3. So you put 3 there and you put 3 there. And there we go. That's your answer. Well, my next question looks crazy. Let's first look at how many terms I have. So I have 1, 2, 3 terms. Okay, it's not that bad. When we factorize, we know we're going to make brackets. We're going to take out highest common factors. So always start with highest common factor first. If you look at that expression, you need to decide, is there a number that can divide into 3, 12, and 18 without a remainder? What is the biggest number, the highest factor of 3, 12, and 18? And that is 3, because 3 can divide into 3, 3 can divide into 12, and 3 can divide into 18. Okay, so part of our HCF is 3. Then we need to look for variables. Can I take out an x? Yes, because each of these yellow terms have x in them. Now, which x do I take out? Do I take out x squared, x to the power of 1, or x to the power of 3? You always take out the variable with the lowest exponent. So x squared, x1, or x3, it's going to be x to the power of 1. Then, can I take out a y? Again, we have 3 terms. All of them have a y in it. So yes, we can take out a y. Which y do I take out? It's either y to the power of 7, y to the power of 5, or y to the power of 1. We're always going to take out the y with the lowest exponent, so it's going to be y to the power of 1. Then, this term over here has a z, but do any of the other terms have a z? No, so we can't take it out. So my HCF is 3xy. Then we open our leftover brackets. Now the way that I'm going to do this may be a little bit different to what you used to. So remember, you can say first term divided by my HCF will get me the number there. Second term divided by my HCF will get me the number there. Third term divided by my HCF will get me a number over there. So we're going to have 3 terms inside my bracket, and that is perfect. That is 100%. But I'm going to ask it slightly, or I'm going to explain it slightly differently. So I'm going to ask, what must I multiply this highest common factor by? What must this number be over here to get 3x squared y to the power of 7? Well, 3 times 1 will get me 3, but we don't have to put the 1 there. X times x will get me x squared. Y times y to the power of 6 will get me y to the power of 7. Why? Because when I add the exponents, then it'll get me that. So 3 times 1 is 3, x times x is x squared, y times y to the power of 6 is y to the power of 7. Or you can just say this term divided by my highest common factor will get me that leftovers. Okay, what must I multiply 3xy by? to get negative 12 x y to the power 5? Well, 3 I must multiply by negative 4. 3 times negative 4 is negative 12. X, there's already a x over here, so I don't put another x over here. Some of my students say to me, but ma'am, why can't I put an x here? Just think about it like this. X, if I had to multiply this in, x times x is x squared. But do you see an x squared over there? No. So we don't put that x over there. Okay. Then we're going to say, okay, cool. Y multiplied by what gives me y to the power 5? This needs to be y to the power 4. Y multiplied by y to the power 4 will give me y to the power 5. And then my last one, 3 multiplied by what will give me 18? 3 multiplied by 6. Then x multiplied by x squared will get me x to the power of 3. Y is already there. And then I would have to multiply this by z. Always distribute to check your answer. So what I mean is, if you multiply 3xy back into the brackets, do I get what I started with? Yes, I do. Right, 1.4. Now, if you look at 1.4, we have two terms. That's one term, and that's one term. Remember, the instruction says factorize, so we must always try highest common factor first. Now, in this case, our highest common factor is actually a bracket. And yes, it may be a bracket. Now, my first problem, however, is the brackets need to be identical. But are the brackets identical? No, the brackets are not identical. And you might say, ma'am, why? They both have x's and they both have 4's. Well, in this bracket, the x is positive, so I'm going to write you a positive x, and the 4 is negative. But look at the next bracket. In the next bracket, the x is negative, and the 4 is positive. So we have to do something called a sign change. And I like to call it a switcheroo. It's basically, we're just going to make the second bracket look like the first brackets. So we're going to keep the first bracket the same, x minus 4, positive x minus 4. The second bracket, I'm now going to make look exactly the same. So you see over here, it's 4 minus x. Nope, I want to make it x minus 4. What I've done is I've made the negative x become a positive x and the positive 4 become a negative 4. But when you change the sign like this, so this is called a sign change. When you do a sign change, when you change the sign like that, you have to pay a price. And the price that you pay is the sign outside the bracket. Okay? The sign directly outside that bracket that you changed needs to also change. So it was a positive, it needs to be a negative. So you have to do a sign change first. Now, if you look at my two terms, we can see that the brackets are identical. Because the brackets are identical, and I'm factorizing, I'm going to take the bracket out as part of my highest common factor. So if I take the bracket out, just take one of them out. Okay, some of my students get confused and they say, ma'am, there's two brackets. Why are you not taking both? You take one of them out. Then you open your leftover bracket and you ask yourself the following. If I divide the first term by the bracket, so if I take the bracket out of the first term, so I'm blocking the bracket now. I took it out of the first term. What are we left with there in the first term? We left with 16. If I take the bracket out of the second term, so if I remove that bracket, what am I left with from the second term? This term over here. I'm left with negative x squared. So we've taken the bracket out. This is our highest common factor. And this bracket over here is what I call my leftover bracket. I divided the first term by the brackets. That got rid of that bracket. I divided the second term by the brackets, by my highest common factor, and it left us with x squared. Now you might think that you're done with the factorizing. No, you're not done with the factorizing. So what I always tell my students is when you think you're done with factorizing, so you've taken out the highest common factor, you've got your leftovers, and you think, cool, I'm done, think again. Always look inside your brackets and think, can I factorize more fully, or can I factorize again? And if you look inside this bracket, I don't know if you can recall from earlier, but this actually, we can do dots. How do I know I can do dots? I've got two terms, 16 and x squared. I've got a minus between the terms. 16 is a square number. That's a dead giveaway that it's difference of two squares. Dots is difference of two squares. And I've got an even exponent. 2 is an even number. So when I do dots, I do the following. First of all, this bracket is going to get carried down into my answer. Then when I do dots, that bracket is now going to split into two new brackets. This bracket, dots, how we always set up dots is we do a plus in the one bracket and a minus in the other. The square root of 16 is 4 and 4. And this should make sense because if I say 4 times 4, I'm going to get 16. And this will be x and x. Because if I say x times x, I'm going to get x squared. If you don't believe me that that's the answer, or if you're still a little bit confused or uncertain, if you take these two brackets here and you multiply them out and you add and subtract like terms, you will get this bracket over here. Okay, so that last line over there, x minus 4, 4 plus x, 4 minus x, that is your final answer. Now my next question looks like this, and it says factorize fully. Remember, when you see factorize fully, you're always going to try highest common factor first. In this question, I cannot take out a common factor because there is no number that can divide into 6 and 27 and 1. I mean, 1 is there, so immediately I know I cannot take out a big number. And I can't take out x because the 27, the third term over here, doesn't have an x. That's a constant term. Then, if highest common factor doesn't work, I want you to think, is this difference of two squares? Well, immediately no, because I have three terms. This is a trinomial. Difference of two squares works with two terms. So this is a trinomial. Now, again, lots of different ways to teach trinomials, lots of different ways that you've probably learned trinomials. I'm going to share the way that I do it. If you do whatever your teacher does and you get the correct answer, that's perfect. Just practice along with me using your method and mark your answer using your method. So the way that I do it is we look for the products of the constant term. So the constant term has no x, so it's the 27. We ask ourselves what multiplied by what gives me 27. And the only one that I can think of is, besides 1 times 27, is 3 times 9. So 1 times 27 gives me 27. 3 times 9 gives me 27. Awesome. Now I need to pick one of these. And the one that I pick, when I add them or subtract them, it needs to give me the middle term. So the middle term is -6. So immediately your mind should be going to this option over here, the 9 and the 3. Because 9 and 3, those are two numbers that will give me 6, okay? But remember, we need a -6, so I'll get to that in a second. The 1 and the 27 is definitely wrong. 27 plus 1 is wrong. 27 minus 1 is wrong. Even if I had to say -27 minus 1, that's -28. That's wrong. So this option is just not going to work. So the option that you choose, when you add or subtract them, it must give you the middle term. But now look at what my middle term is, grade 9s. My middle term is -6. So I need to make these two numbers, 9 and 3, when I add or subtract them, it must give me -6. So I know a lot of you will say, ma'am, that's easy. It's 9 minus 3. But think carefully about that. 9 minus 3 is +6. So that's not going to work. It can't be a +9 and a -3. Remember, I needed to give me a -6. If you say, okay, ma'am, what about, let's try 3 minus 9. What about that? Does that work? +3 minus 9, or you could say -9 plus 3. This and this means the same thing. -9 plus 3 is -6. So that is what I'm working with. I'm working with a -9 and a +3. And then you also just need to double check for me. If I say -9 multiplied by +3, does that give me, if I multiply these two together, does that give me -27? Yes, it does, because a negative multiplied by a positive is a negative. and 9 times 3 is 27. So therefore, my expression is my factorizing. When I factorize it, it's going to look like this. So we're going to have two brackets. So it's kind of like difference of two squares in that we have two brackets. We're going to have an x and an x because x times x will get me that x squared. And then remember we said we need to use a negative 9 and a positive 3. The reason why is because if I have to distribute this, so let's do it quickly. To check, you just distribute x times x is x squared, x times 3 is 3x, minus 9 times x is, negative 9. Negative 9 times positive 3 is negative 27. Do you see when I add or subtract them, there should be an x there, positive 3x minus 9x, that gives me negative 6x, and then the negative 27. So when I add or subtract them, they give me a negative 6, which is the middle term. When I multiply them, they give me negative 27, which is the last term. So this is my answer, this one over here. The stuff that I've done at the bottom is just to check my answer. Let's do one more trinomial so that you feel comfortable. First of all, you have to try highest common factor first, or think if highest common factor will work. It will not. We can't take out an x. We can't take out a big number. We can't do a difference of two squares, so it's going to be trinomial. So 14 is 1 times 14 or 2 times 7. Remember, we need to choose the combination that when I add or subtract them, it's going to give me the middle term, which is negative 5. So this option makes sense. But remember, I need to make a negative 5. So the way that makes sense to me, you'll see that it can't be 7 minus 2. Because 7 minus 2 gives me positive 5. But I don't want a positive 5. I need negative 5. So if I do negative 7 plus 2, that will give me negative 5. You owe the tuck shop 7 rand, negative 7, plus 2, you pay them back 2 rand, you still owe them 5 rand. And also, if I take negative 7 times 2, I'm going to get negative 14. So either way, when I add or subtract them, it gives me the middle term. When I multiply them, it gives me the last term. So my answer is x minus 7, x plus 2. There we go. Another factorizing question for you. You might see two terms, a minus in between, and you might start thinking, oh, ma'am, I know this is difference of two squares. But remember, what must you always do first? You must always try highest common factor first. Just remember that, please, because even if you had to see something like this, let's say plus 10x, and let's say minus 12. You might see something like this and get excited thinking that it's a trinomial, but you first have to take out the highest common factor, which is 2. And then you would do a trinomial. So your complete and final answer would have a 2 on the outside because you would have to take the highest common factor out first, and then this you would do a trinomial and it would give you 2 brackets. I hope that makes sense. If you want me to do more like that, please let me know in the comments below. So for the one on the screen, how would I do this? I would first have to try highest common factor. So we've got this term and we've got this term. I know 5 goes into 45 and 5 goes into 5. So I would have to take out a 5. Then, can I take out a y? No, because my second term doesn't have a y. Then you would open up your leftover brackets. What must I multiply 5 by to get 45? Well, you must multiply it by 9. So that would be 9y squared. 5 times 9y squared will be 45y squared. And then 5 multiplied by what will give me negative 5? 5 multiplied by negative 1 will get me negative 5. Or you could have said negative 5 divided by 5 gives me negative 1. Then you might think, cool, ma'am, I'm done. I did highest common factor, but I hope those of you that look carefully will see that we actually still can factorize further. So if you look inside this bracket, I can do another type of factorizing. I hope you can see what it is. It's called difference of two squares. Now, ma'am, how do you know you can do difference of two squares? Well, if you look inside the bracket, ignore the 5 now. Look inside the bracket, the purple that I've underlined. We've got two terms, 9y squared and 1. We've got a minus between those terms. We've got square numbers. 9 is a square number and 1 is a square number. And we've got even exponents. Okay, 2 is an even number. So how we do it is we carry down that 5 and dots, difference of 2 squares, we need 2 brackets. We have a plus in the one, a minus in the other. The order doesn't matter. You can put the minus first. We square root the 9, we get 3 and 3. And then y squared, if we square root that, we get y and y. It makes sense because 3y times 3y is 9y squared, because remember, you'll add the exponents. The square root of 1, some people forget, but the square root of 1 is 1. So that would be a 1, and that would be a 1. And that's your final answer. Another thing to look out for in the exams is the mark allocation. So the mark allocation for this question might be 3 marks. So you might think 3 marks, that's weird. So if you had to stop here, surely the 3 mark allocation would be a bit weird for you. Because if you just do the first line, how are you going to get 3 marks? It's just one thing. So if you see 3 marks, 4 marks, or whatever, just think you may need to factorize more, but you must always check. If you need help with simplifying or solving, remember to check the links in the description below. See you for another video. Bye everyone.